Produced water course. So what we need to do there is it's a 5-day course for around about 20 people, and it's going to be a basic course that involves the main parts and processes of the produced water treatment facility. Very basic flow diagram for that is here. And so we have the produced water is the dirty water basically that comes out of the separation process on the wet crude trains at DS6, DS7 and DS8. We've recently increased the number of wet crude trains. There were 4 trains originally, one of which was a wet train. Recently that capacity to separate wet crude has increased because, of course, the amount of water injection that is being undertaken in order to sweep the oil and keep the reservoir pressures high is increasing. And as a result of that, the oil that's coming out of the ground is increasingly wet. So the separation facilities have been upgraded to treat more wet crude. As a result of that, in treating the wet crude or in separating the wet crude, one of the big byproducts is produced water. And the produced water is a mixture of salt. It's dirty water. It's salty, dirty, oily water. Up until now, or at least in the last couple of years I've been here, because this has not been a big proportion of the separation process, it's only been around about 1/4 of the separation process, there hasn't been an enormously high amount of produced water being a byproduct of the separation process. And what they were doing, which is not really a legitimate way of treating it or processing it, they were just pouring it into a big pit that was out in the field. And so they would just pour this into big pits. A tar-like residue would form on top of the pit, and that would cause number one, that would make it very difficult for the water to evaporate because it had this tar-like sort of skin on top of it. And number two, it was really sort of not a very courteous way to treat the land and the environment, just, you know, pouring this dirty water into big pits around it. So now the amount of produced water is increasing dramatically because the wet crude facilities have been upgraded to handle a lot more wet crude. They're actually they have constructed and are going to commission a produced water facility that will treat the produced water and basically clean it up to a condition that is then acceptable for them to inject it. And so it goes back into the water injection cycle. Comes out of the reservoir, usually because it's been injected. It gets separated from the crude oil. Crude oil heads off for export. And the produced water that will then go through the produced water facility, become clean, and then get injected back down into the reservoir. So it'll be kind of like a cycle. There's a lot of extra water getting injected down into the reservoir. And so, but yeah, this produced water will be kind of cycling around and through. Yeah, it's not a perfect cycle, obviously. It's certainly not a closed cycle. And so that's the case. That's what's happening. And so from each of the wet crude facilities at DS6, DS7 and DS8, the produced water comes primarily out of the dehydrator, and it will go into first port of call will be these pre-separator tanks. And these pre-separator tanks will perform the same sort of purpose as the skimmer in the old wet crude trains. There was a skimmer, and that was basically a vessel where the dirty water would go in, the dirty oily water would go in, the oil would rise to the top, and then it would be skimmed off and put back into the balanced vessel, which is one of the oil vessels that is before the dehydrator and the desalter. And so that was basically a means of recovering that valuable oil instead of just pouring it off in with the water into the pit. So that same process will happen at each of the stations in this pre-separator tank. I'm not sure how big it is. I think it's about 1,200 meters cubed, 1,200 cubic meters. And so it'll sit in here. The oil will separate at the top, and it will be drawn off the top. It'll float into a funny little weir, apparently. And so the tank's kind of like this. There's a little weir at a certain level. There's a weir, and so the level of the water and oil goes up. It'll be an oil film or a skin of oil or a top layer of oil at the top, and that will go over this weir and collect in this trough, which runs around the circumference of the tank. When the trough level of oil gets to a certain point, this pump will kick in, and it's called the pre-separator recovered pumps. The pre-separator recovered pumps, there are 2 of them at each station, and it's 2 by 100%. So there's one working, there's one on standby. So one of these will kick in when it gets to a certain set point, and it will return the oil to the balanced vessel, which will then, and that's putting it back into the crude oil separation process. So we're able to recover this valuable oil. And so that's one part of that. The other part of this is the water, which is pre-treated. So it's in the pre-separator tank. It's pre-treated water, hasn't really been treated at all yet, not treated. The oil is still very salty, and it's oily. It's got, this is what I think they call the free oil that comes out. But yeah, there's plenty of oil still in this water in an emulsive sort of state, and there's a lot of sediment and sand and stuff. I wonder how, there must be sludge collecting here, and I guess they drain that somehow. Anyway, so the pre-treated water then gets, goes through this pump from each of the stations to a big central tank here. This big central tank, I think, is just twice as big as these, funnily enough, not 3 times, but twice as big as these. I think it's 2,400 cubic meters. So it gets pumped from each of the stations through these pumps, and they're called pre-treated transfer pumps. 2 of them, 100%, so one on standby, one running. Now, these won't click in and out. They'll be going constantly in normal operation. They'll just be continuously running. Of course, they have a recycle loop in case, something shuts down here and they have to, just go around. And so the water then goes through these pre-treatment transfer pumps. I don't know what the suction and discharge pressures are, but I'll find out. Yeah, they then sort of commingle here and go into the produced water tank. That is the big produced water tank at DS7. And the rest of these facilities are all at DS7. So we have a pre-separator tank at each of the degassing stations, 6, 7, and 8. And then we have the produced water tank at DS7, and the bulk of the produced water facilities are at DS7. And so, of course, this is at DS7. This is DS6, this is DS8, this is DS7. I might be reading that wrong. We're at DS7, DS8, DS6 here. But anyway, so one of these tanks is actually sitting right next to this tank because it's the DS7 pre-separator tank. The other 2 are off at the other degassing stations. And so when you see the produced water facilities at DS7, you'll see actually a pre-separator tank, which is the DS7 tank. You won't see the DS6 or the DS8 tank. They're miles away. And this small one is next to this big one. The big one's the produced water tank. So still at this stage, the water has not been treated. This is untreated produced water. We can call it dirty water. I'm calling it, I'm calling it, and I might, in talking to the guys about it, I might call this very dirty water, this dirty water, and this clean water over here. Call me crazy. So this, from here, we have a pump that then pushes it through the filtration and cleaning process. There are 3 stages of the filtration and cleaning process. well, first we go into the pump, and there are 3 pumps, and they're called the produced water transfer pumps. There's 3 of them at 50, so there's 2 of them working full time and 1 on standby. The first stage after the pump is this thing. It's an induced gas flotation. Are we going to call it a filter? Induced gas flotation package. It's a package. It's a strange type of filter. It's a filter that works like this. Basically, the produced water runs through here, running through a series of chambers. At the bottom of the chamber, there is an injection nozzle, and running through this nozzle is a mixture of cleanish water, not clean, but a little bit clean, water and gas. The gas, the water and gas hits a striker plate, which spreads it out at the bottom of the chamber and disperses the gas into tiny little bubbles around the bottom of the chamber. And so here's our chamber actually. And so I think there are 4 chambers, then it goes into a larger vessel. So the water comes in and it is channeled down because of a weir here. So the water comes in, goes down, and here we have an injection nozzle where cleanish water and gas will come in. It hits a striker plate, and now let's put this in the middle. Hits a striker plate, and the gas disperses horizontally, more or less, into tiny, tiny little bubbles, and that creates like a filter, if you like, of little bubbles that are rising to the surface through this water as it travels, and the little bubbles connect and stick to oil and solid droplets, oil droplets and solid sediment pieces. And so the gas bubbles will connect with these, grab them, and take them to the surface. What will happen then is at the surface there is a formation of froth. And the froth is the collected oil and solids that is collected by the gas bubbles that are rising through the water. This froth then is skimmed off by a series of, basically a series of weirs, basically. And so we've got a couple of examples of this. There are different types of IGF packages, induced gas flotation packages. There are different types of them. One that I have seen has basically a trough, like a little canal, like a little, and it's a V-shaped thing, and it enables this froth basically to spill into it at a particular set point. And then it really just runs down. Is it sucked out? I think it kind of is, but basically there is a gas blanket here. The gas blanket I think it's just gas out of the first stage separator. I don't think it's nitrogen. Might be nitrogen. It's a zero oxygen gas in any case to stop oxygen getting into the water, which we don't, obviously we don't want oxygen in the water for a lot of reasons. And so, this all happens under a bit of pressure, I'm sure. How much pressure? I don't know. I'll check. There must be a pressure for the gas blanket here. And maybe it's high pressure. It might be like 5 kilos or something. Don't know. But in any case, the froth just spills out into this channel, and I think it's pumped out. Can't just run out, can it? Into this last chamber here, it's kind of like a bit of a settling chamber, and once again we get a bit of an oil film at the top, and that is, I think that spills over a weir and is somehow is channeled off in a different direction. But what's coming out of here is not very clean water, but reasonably clean water. Cleaner than it goes in, that's for certain. There's a couple of specifications about how much oil is going in and what's the oil content coming out, and it's some type of parts per million or whatever. There's also an amount of sediment going in and out. I don't know exactly what they are. To be honest, I think it's the sediment only goes down to half, but the oil goes down a long way, is my understanding. What else is going on there? So that's that stage. This water that's getting injected in here and inducting or educting, I'm not even sure which, inducting or educting the gas, this water is actually just this semi-clean water getting cycled back through. There's a pump here, and according to this flow diagram, which might not be absolutely 100% accurate, according to this, there are two gas induction pumps. You can see them here. And they're 2 by 100%, so one will be working, one will be sitting on standby. Yeah, it's just channeling this semi-clean water back through the system in order to get the gas bubbles, which is basically what creates the filtration process inside this IGF package. Now, what I should say that I did not say before is this. There are two of these. There is one big tank, there are 3 big pumps, but of this stuff here, there are 2 lots of these. There are 2 trains in tandem, and so they are both capable of, each has a capacity of about 45,000 barrels of water a day. So it's a total of 90,000 barrels a day. Basically 30,000 barrels a day are expected to come from each of these 3 stations, 90,000 barrels a day, 45,000 barrels a day between by each of these 2 trains, 90,000 barrels a day. After we get out of the IGF, the gas filtration, gas bubble filtration thing, we go into a nutshell filter, Interesting. Nutshell, you say. Nutshell filter. The nutshell filter is exactly what it says it is. It's a media filter, like a multimedia filter that we had at the Mod 300. At the Mod 300, we had multimedia filters where the water would come in at the top and it would sink through these layers of gravel and stone and sand. And these layers, you know, like the way water purifies it at the beach or running down a stream, it runs through basically layers of gravel and sand and things that pick up the, you know, the small bits of flocculant and stuff like that. And so after the water runs through the gravel and sand and etc., it comes out here very clean. All the bits and pieces get stuck in here. After a while, of course, you get too many bits and pieces here, so you have to stop this process and do a backwash. And the backwash mixes up all these media, the sand and gravel, and lets the particles become free, and they go off into basically a dirty backwash channel that goes into usually a sludge recovery process where they pull the sludge out and they deal with it in some other way. That certainly happens. Now, that is exactly what's happening with the nutshell filters. Why is it called a nutshell filter, you might ask? Because of this. Instead of gravel and sand, what we have is crushed black walnut shells. Crazy as it seems, that is a wonderful media to collect the oil and solid particles from the water as it flows through this layer of nutshells. And that's exactly what happens. The oily water, you know, semi-clean water coming out of the IGF, it comes into the nutshell filter at the top, goes through the nutshell layer, comes out a lot cleaner than when it goes in. Why do they use nutshells? A couple of reasons. They're good for picking out the oil and and solids out of the water, number one. Number two, they're very easy to backwash. They're kind of light and they're free. And so when you have to, you've got too much of this stuff in there and you have to clean it, you stop this process. There are three nutshell filters for each IGF package. So there are 6 in total. IGF package, 3 nutshell filters for each. And so at any stage once a day, normally one time a day, these will shut down and backwash. And they shut down and they backwash for around about 10 minutes. There are about 6 separate stages of the backwash process. One stage is it shuts and it'll divert to the other 2 nutshell filters. The second one is, I think there's an agitation. There's like blades in here that will just blub, 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 blub all these up. And then there's a cleansing process and stuff like that. We can go into more detail of that later on. So that's basically how it works. And the really grubby, grimy stuff, all the bits and pieces, then get expelled out and they go to a clarifier, which is really kind of like basically a sediment vessel where all the sludge will go to the bottom. It comes out of the bottom, or it gets sucked out of the bottom, and it gets sucked out of the bottom on a regular basis, a periodic basis, by a big vacuum truck which just backs up to the facility, connects its hoses, and pulls the sludge out of this clarifier and takes it and puts it in the soup tureen at the defac. No, it does. No, of course, it takes it and does something else with it and disposes of it in an environmentally acceptable way. So back to our water. And that's how the nutshell filter works, basically. And that's what the backwash does. But in normal operation, you've just got the dirty water or the semi-clean water coming from the IGF, coming through the top of the nutshell filter, out of the bottom of the nutshell filter, very clean. It then goes into another filter, and the other filter is called a cartridge filter. These are all very close together. You can see here the cartridge filter is quite a long way. There's the nutshell filter. There's the IGF. There's another pump. And that pump is the treated water transfer pump. We're calling it treated. That means a little bit clean, but not very clean. Nutshell filter. Then and so from the nutshell filter, when it does a backwash, it spews all the muck into the clarifier. And the clarifier will deal with that, sludge away. Also recovers some oil, the clarifier, and I guess it goes back to the balance vessel, does it? Probably. The next stage for the water, though, the main flow of the water doesn't go up here. It goes along here to the cartridge filter. Cartridge filter is actually very close to all this machinery, but here it looks like it's separated. It's not really. Cartridge filter, as far as I can tell, it's a big chamber into which they put a filter that is like a big spongy thing, and it's called a cartridge filter because this big spongy thing is a disposable cartridge. You pull it out when you need to, and you put it back in. I think that's the nutshell filters are a 24-hour backwash system normally. The cartridge filters are I think they run for 30 days before they have to be changed. And when they're changed, it's very easy. You just open the whole thing up. It's kind of like got a handle with a hinge here. You open it up, pull the thing out, close it back up. How many cartridge filters are there? Can't remember. Look, there's 2 for each train. I can remember. There are 2 for each train. 2 by 100%. There are 2 for each train, and they're 2 by 100%, which means, this one reaches its limit, so you just divert to this one and change the filter on this one. No problem. After it leaves the cartridge, the water that's pretty much as clean as we're going to make it. And from there, it goes into a big tank that is called the water injection tank, and that's the end. That's the end of that system. One little thing I didn't mention was, and there are many things I haven't mentioned, but one other thing I do know is that with these nutshell filters, a backwash cycle is, there are three ways it can happen. Number one, it just happens automatic timer basis, which is between 20 and 24 hours. So there's an automatic timer basis, and as soon as it hits 22 hours, if it hasn't had a clean for 22 hours, bang, it goes into a backwash cycle. Number two way is if the differential pressure, so the pressure coming in here, pressure going in here, if the differential pressure becomes high and reaches a set point, it'll initiate a backwash cycle. Now, obviously, the more crap, the more rubbish and waste that you have choking up this nutshell layer, the harder it is for the water to flow through, and the greater the differential pressure. And so that's why it will reach a differential pressure set point. And so, for instance, it's been running for 10 hours. It's not ready. It's not scheduled for a backwash for another 10 hours. But there's so much rubbish in there that it's not going to work effectively. Differential pressure set point will be reached, and that'll initiate a backwash for it. Number three, the third way it can initiate a backwash is if you press the backwash button, and it'll do a backwash for you. That's pretty much it. That's the whole damn thing explained in 30 minutes. Any questions? Just give me a call, and I'll ask you to go and speak to one of the technical guys, which will be Sammy or Abdul Amir or one of the technical trainers, or go and talk to Uncle Tony Cardoso. He'll sort you out in terms of how this thing operates. Over and out. Now, just something I should add here is that I am the technical English teacher. I'm not the technical instructor. And so in learning the technical English that they will need to learn in order to understand the instructor, of course we talk about the parts and the processes. That's inevitable. But at every stage, the trainees are made absolutely clear that they are not learning how to operate this. They are just learning the English terms for the main parts and processes. They are certainly not learning any details about how it works, how it stops and it starts. It is absolutely the very broad brush strokes. I want to make that absolutely clear, that the trainees are absolutely clear that in any question of how this operates, they go to the technical trainers or the startup leads, or they know that what we're doing, they know that what I'm doing with them is purely English, and that's it.